Tonight you will turn off the light, pull the blanket up, and close your eyes. Within minutes you will hear it. A thin whine circling somewhere near your head. You will slap at the dark and miss, and in the morning you will count the bites down your arm while the person who shared your bed walks away with none. You will blame your blood type. Maybe the beer you had earlier, maybe just bad luck. But the real answer is far stranger than luck, and it has almost nothing to do with your blood. It has to do with a smell you are making right now, one you cannot wash off, cannot outrun, and did not choose. You have been broadcasting it since before you could talk. Start with the insect itself, because most of what you think you know about her is wrong. Only females bite. Males spend their short lives drinking nectar and never touch a person. A female bites because she is building eggs, and eggs need protein and iron, and the richest source of both on the planet is sitting under your skin. She is not hungry. She is shopping for raw materials, and she is not even especially interested in humans as a rule. Most mosquito species will happily bite a bird, a cow, a frog, whatever warm body happens to be closest. The kind that ends up in your bedroom is different. Somewhere in her evolutionary past, one branch of her family tree specialized. It stopped feeding on animals in the forest and moved in next door to people, rebuilding its sense of smell around exactly one species. Yours. So she is not hunting blood in some general sense. She is hunting you, specifically, using a nose built for one target. And that hunt happens in two completely separate stages, which is the part almost nobody explains correctly. Stage 1 starts far away, sometimes 30 feet or more. At that range, she cannot see you, cannot feel your warmth, cannot smell your skin. What she catches is carbon dioxide, the gas leaving your lungs every time you exhale. It drifts off you in an uneven trail, and the moment she crosses it, a switch flips in her brain. Not there is a person, just there is something worth chasing. She turns into the trail and rides it upstream, losing it, finding it again, getting closer. Then, at close range, something else takes over. For a long time, scientists assumed she was following body heat the way a heat-seeking missile might. A study out of the University of California, Santa Barbara, tested that assumption directly in 2024. Researchers built a warm surface and blocked the actual hot air rising off it, leaving only infrared radiation crossing the gap. The mosquitoes went after it anyway, in greater numbers than before. She is not just feeling warmth. She is detecting infrared radiation the way a thermal camera does from about 2.5 feet out. So by the time she is hovering near your arm, she already knows two things. Something is exhaling and something is warm. That is enough to find a human being. It is not enough to find you specifically, because everyone else in the room is exhaling and radiating heat too, which raises the real question this video exists to answer. Out of every warm, breathing person in that room, why does she land on one and ignore the rest? The answer is sitting on your skin right now, and it is not blood. It is oil. Your skin produces a thin film called sebum, meant to waterproof you. On its own, sebum barely smells like anything, but your skin is not sterile. It hosts something like 1 trillion bacteria, quietly feeding on that oil and breaking it down into smaller compounds, including a group of sharp, sour molecules called carboxylic acids. Those acids are what actually drift into the air. That faint locker room smell after a long day is not you. It is your bacteria's exhaust. In 2022, a research team led by Leslie Voschall at Rockefeller University ran an experiment that made this brutally clear. Dozens of volunteers wore nylon stockings on their arms for hours, and researchers cut the fabric into pieces and tested them against each other in a straight competition, letting mosquitoes vote with their flight paths. One volunteer, recorded in the paper only as Subject 33, pulled in roughly 100 times more mosquitoes than the least attractive person in the group. Not twice as many, not 10 times, 100, and when they repeated the experiment years later, the rankings barely shifted. Whatever made Subject 33 a magnet was not a mood or a meal. It was closer to a fingerprint. This is not new information to mosquitoes, even if it surprised the scientists studying them. Back in the 1990s, a Dutch researcher named Bart Knols noticed something odd while working on malaria mosquitoes in Africa. They were unusually drawn to his feet. Curious, he tested them against a piece of Limburger cheese, and the mosquitoes responded to it almost the same way they responded to a human foot. The cheese is ripened using bacteria closely related to the ones living between your toes, and both produce nearly identical acids as they break down fat. The mosquitoes were never chasing a person or a cheese. They were chasing a smell, and it happens that feet and a certain soft cheese make the same one. So if bacteria are doing the work, the obvious next question is whether more bacteria means more bites. A 2011 study out of Wageningen University sampled the skin bacteria of dozens of men and compared it to how often mosquitoes targeted them. The pattern was almost the opposite of what you'd expect. The men who attracted the most mosquitoes did not simply have more bacteria. They had less variety, a narrower mix of species producing a stronger, more concentrated version of the same signal. The men who barely got bitten carried a broader, messier bacterial community, and something in that mix seemed to blur the scent, making it harder for a mosquito to lock on. Diversity, not cleanliness, may be doing the protecting. Can you change any of this? Barely. In 2015, researchers at the London School of Hygiene and Tropical Medicine tested attraction in twins, offering mosquitoes a choice between one twin's hand and the other's through a simple Y-shaped tube. Identical twins, who share essentially all their genes, were chosen equally often. Fraternal twins, who share only about half, showed a clear favorite almost every time. That is about as strong a signal of genetic control as biology gets. Your appeal to mosquitoes appears to be inherited, not earned, passed down the way your height or your eye color was. There is exactly one variable in all of this that you can control on any given night, and it will not help you much. A study conducted in Burkina Faso found that men who drank roughly a liter of local beer became measurably more attractive to malaria mosquitoes within about 15 minutes, while men who drank water saw no change at all. Nobody has fully explained the mechanism. What is clear is that the lever only moves in one direction. Drinking makes you a slightly bigger target. Not drinking simply leaves you exactly where your genes and your bacteria already put you. Here is the twist that should bother you more than any of this so far. If mosquitoes are steered almost entirely by smell, the obvious fix is to break their sense of smell. Scientists have tried exactly that, using gene editing to delete the receptor mosquitoes used to detect carbon dioxide, then releasing the modified insects into a room full of people. The hunt barely slowed down. They deleted entire families of odor-detecting genes next, expecting the mosquitoes to go blind, so to speak. They still found the humans. The reason is wiring, not willpower. In most animals, each smell-sensing nerve carries a single type of receptor, so damaging that receptor damages that sense entirely. A mosquito's nerve cells carry several different receptors stacked together, tuned to different chemicals, all reporting through the same line. Cut one route to you, and the others simply pick up the slack. There is no single wire running to your scent that anyone can snip. Which is why the most promising defenses today do not try to disable the mosquito at all. They use the same chemistry against her, deploying traps loaded with that same cheesy, foot-like scent to outcompete the actual humans sleeping nearby. A strategy already running in parts of Africa where the stakes are measured in lives rather than itchy ankles. And the stakes really are that high. Malaria alone is estimated to cause hundreds of millions of cases and several 100,000 deaths a year. Most of them young children, mostly in places where a bed net is the difference between a mosquito being an annoyance and being a death sentence. No large predator you could name, combined, ends nearly as many lives per year as this one insect does, delivering a parasite riding in her saliva while she looks for exactly what your bacteria have been advertising all along. Which brings us back to your bedroom and the part of this that lives entirely in your head. You remember every one of your own bites and almost none of anyone else's because you were not paying attention to their arms, only yours. That is not a mosquito problem. That is the same bias that makes you feel like you always get the slowest checkout line or the red light every single time, when really you only remember the times it happened to you. Some of what feels like persecution is simply selective memory wearing an insect costume, but not all of it. If your particular blend of skin bacteria happens to produce a louder version of that scent, the mosquito in the room is not choosing you by accident, and she is not choosing you out of cruelty either. She is following a signal that has been broadcasting from your skin since long before you noticed the first bite, one written into your genes and rented out to a colony of bacteria you never agreed to host. So tonight, when the light goes off and that wine starts circling again, you will not need luck to explain it, and you will not need bad blood either. Somewhere in the dark, one mosquito already knows exactly where to find you, not because chance pointed her your way, but because your own skin has been giving her the address the entire time.